Good morning, students. In the previous classes, we have just continued the memory systems, the topics. We have covered your characteristics, the hierarchy, then about semiconductor RAM, then different types of ROM, then the concept of and different types of intelligent memory. So today we are going to study the cache memory. Okay. So let's study the cache memory. So dear students, uh, first of all, before going to study cache memory, we should know what is cache memory. What is cache memory? So it's a small and high speed RAM. Typically, it is a SRAM. Okay, and the name is cache. The meaning of the cache is to hide, and where it is hide between the CPU and the main memory. Just look into the diagram. So there is a CPU. So this is CPU, and this is your main memory. Okay, so it is placed in between cache. There is a memory cache. The meaning of the cache is to hide. So it is placed in between CPU and main memory. So now we'll think that we have main memory. Okay, we have main memory, and also we know that we have register memory. So for temporary storage of data during program execution, we also have register memory. So now the question is that again, what is the need of the again another kind of memory which is known as cache memory. So we should know that why we will use cache memory. What is again the need of the cache memory? So as now I have told you that it's a small and fastest memory. Then what is again the need of the, as we know that register is the fastest memory, main memory is known as the executable memory. Then again, why we need cache memory? So there are some points to be discussed that why cache memory. The first point we should discuss that it is due to fast, because first means the execution should be fast, as the primary memory or the main memory or executable memory, whatever you called, the main memory is typically it's a DRAM. Okay, and the cache memory is SRAM. As per our knowledge, we know that SRAM is much more faster than the DRAM. So, if we place a small memory between the CPU and the main memory, then the execution can be much more faster than before. Okay, and the next concept is that another concept is that during program execution, the a localized area of data, a particular localized area of data is being placed, uh, is being used by the CPU more often. That means what? CPU is going to refer a localized area of data very often. So our task is to place that localized area of data, or that more reference data, to the cache memory. So the combining 2 points, that due to the first in nature and due to the localized area of data, we need a cache memory. So the concept is known as locality of reference. So what do you mean by locality of reference? Locality of reference tells that cache memory holds a copy of the instruction or data that is currently being used by the CPU. So there are two kinds of locality of reference. The first one is your temporal, and the second one is your spatial. Okay, So temporal locality of reference and spatial locality of reference. Okay. So before going to CAS read operation, I just want to tell you some points that CPU always, the processor always seeks the data, always seeks the data from the cache memory. CPU is unaware of the fact that there are different kinds of memory, main memory, register memory, cache memory. CPU is unaware of the fact. CPU always searches for a particular word which is required in the cache memory as a default. Okay. So as it's a memory. So obviously there should be a read operation and there will be a write operation. So let's study the cache read operation. Okay. So read is meant by what CPU needs a particular address, CPU needs a particular word, and it is going to search within the cache memory. So when the CPU needs to access memory, then obviously the cache is first searched. Okay. And if the word is found, if the word is found, it is known as cache hit. That means the concept is known as the cache hit. Why the concept? Why if the word is found? Why the concept is if? That means what? There is another probability that the word may be found, may not be found. Why so? Because we know that as we are placing the frequently used programs or data in the cache memory, so there is a question that maybe the word is found, maybe the word is not found. So that's why if the word is found or it is read, then it is known as cache hit. Then in the contrary, if the word is not found, if the word is not found, then the main memory is referred. Obviously, always we know that main memory is the executable memory. So obviously main memory is going to refer as finally, and it is known as cache miss. That means what? The cache is missed for the particular word for what CPU was meant for. CPU uh, CPU searched for a particular word and the word is not found, so that's why it is missed in the main memory. It's missed in the cache memory, but it is found in the main memory because we have placed a uh, a copy of that particular frequently used data in the cache memory. So now the question is that if we will place a cache memory, then obviously we we want we means the architecture always wants that the cache should be hit all the times. That means what? We'll measure the performance of the cache memory by using a particular term which is known as heat ratio. Okay. So what do you mean by heat ratio? Always the term ratio means something divided by something. Okay. So heat ratio means we'll measure the cache memory performance by dividing the total number of cache set by the total number of cache access. Okay. So here you can see that we calculate this performance parameter of cache memory. Heat ratio is equals to total number of hits by total number of hits plus total number of miss, or you can call it as the cache access. Total number of hit divided by total number of cache access. Okay. So now I just want to add some more points over it, that let's say we have placed a cache memory. Okay. We have placed a cache memory. So it is required that we want that the cache should be hit each and every time. Let's say for an example, I will give you an example that to access the cache memory, I required 1 nanosecond. Just think, to access a word in the cache memory, the access time is 1 nanosecond. Okay, and if it is found, then the obviously the cache access time is equals to 1 nanosecond. Next, if it is not found, if it is not found, then we have to go to the main memory, and here the cache miss occurs. Okay, and again, to search into the cache memory, let's say the access time is 2 nanosecond. The access time is equals to 2 nanosecond. So there is if we will calculate in case of a cache read, then it is 1 nanosecond. In case of a cache miss, it is first it is missed, that is 1 nanosecond, plus again it is searched in the main memory, that is equals to 1 nanosecond plus 2 nanosecond. So total access time will be 3 nanosecond. So let's say assume that we don't have any cache memory. So in that case, obviously we are going to found a particular word in the main memory, all which there is no case of any miss in the main memory. So obviously there is a there is what the total access time will be obviously less than the catch hit access time plus catch miss access time. So here if I will calculate that first for 1 nanosecond plus again for miss for 2 nanosecond, so total 3 nanosecond. If a hit occurs, then it is 1 nanosecond. Okay, if a miss occurs, first we'll go to the cassette because it's a default, then plus 2 nanosecond for cache miss, so total will be 3 nanosecond. So we can call it that we also cannot assume that we can also cannot confirm that there will be no cache miss, but we can assure that, let's say for the first time cache miss occurs, for the first time cache miss occurs, so we have to assure that we will we should take some precautionary steps, that there should not be again some cache miss, because unnecessarily it will just increase the cache access time, because cache hit again cache miss, again we have to move to the your main memory. So we have to ensure that cache miss should not occur. Okay, so let's move to the next uh, after cache read we'll move to the cache write. Okay, so what is cache write? Okay, during a read operation, CPU found some word in the memory. Okay, we just studied it. Okay, then the main memory is not involved in the transfer, obviously. Okay, so cache write means what? As we know that cache is the temporary storage. Obviously main memory is a temporary storage. That doesn't mean that cache is temporary, main memory is not temporary. Cache is also temporary, main memory is also temporary, but main memory is the executable memory. Okay, for faster purpose and for locality of reference purpose we use the cache memory, but main memory should be updated each and every time during program execution. Okay, that concept is known as write back. So at the end of the each instruction execution, the main memory should be written back. And now we have studied that always CPU searches the word or write the word to the main memory, to the cache memory, sorry, to the cache memory. Okay, so main memory should be involved in the transfer. Okay, so main memory is need to be updated. Okay, and this updation is known as cache write operation. So updation means what? When the main memory get updated, obviously the cache memory need to be updated. Okay, and this write operation is completed by any of the ways. We have two kinds or two ways or two approaches the writing operation. One is write through, another is write back. Okay, write through or write back, the will go by the meaning write through. Write through means what? At the same time, at the same time, the cache memory and the main memory should be written at the same time. That means what? The updation should be done in parallelly. Okay. But the thing is that, as we know that main memory is busy in other activities. Okay. In sometimes it may not possible. It may not possible to update the cache memory and the main memory at the same time. So the next approach is your write back. Okay. The next approach is write back. Okay. So write back. We'll go by the name. Write back means what? We will first update the cache memory, and then after we'll update the main memory, or vice versa. Okay. First, a small line should be updated, or some kind of some 3 to 4 instruction, or the 3 to 4 results will be written back, and then a flag should be set. Because how we will know that the as a small portion is written to the main memory or the cache memory. Okay. So as the result is with the cache memory, this should be updated to the main memory. And there is a need of one, we can call it as a pointer, we can call it as a yeah, we can call it as a pointer. Okay. And it is known as it's a flag is to be set. Okay. A flag is to be set. Okay. So extra hardware devices required. By looking into the flag, we can we can know that this much of writing, or this much of updation has completed. Next updation should be done from this afterwards. Okay. So in this way the cache is being written. Now the next concept, most important concept, is your mapping. So before going to mapping, I should tell you that why we need map. So map is a term which is used that we will map something into a something. That means what? Uh, let's say we call it as we will map a geographical place. We will map a geographical area from a particular place to another particular place. That means what? Before mapping, we should have some certain criteria. Like, if I will map, uh, let's say, in coming to this cache memory, then I should map. Now the question is that cache memory and main memory always. Okay. So the cache memory is to be mapped into the main memory, or it is not exactly the fact. The fact is that main memory is to be mapped to the cache memory. So obviously there is a transformation of information. Some kind of transformation is happening between the main memory and the cache memory. It is known as the by definition, if we'll go, then mapping is defined as the transformation of information from main memory to cache memory is known as mapping. Okay. So what is happening between this mapping? Mapping it's used to map the memory blocks onto the corresponding cache block. Now the thing is that we have to find out that which block of main memory has mapped to the which block of cache memory. Okay. So there are certain kinds of approaches. Okay. We if we will just discuss in a very rough manner, then any block of main memory can map to the any block of the cache memory. Okay. And if we will apply certain kinds of rule, that by applying a rule that a particular main memory block will be mapped to a particular cache memory block. Okay. So there are different kinds of approaches, different kinds of algorithms are there. So depending upon that, we have three kinds of mapping function. One is direct mapping, another is associative mapping, another is set associative mapping. So we'll discuss one by one. First one is your direct mapping. as the name is direct mapping. Why will go by the name? Here, direct mapping means what? Mapping is done by applying a certain kinds of rule. Okay. Here, the let's say M. M is the block of block number. You can call it as the block number of the main memory. It is to be mapped to the cache memory. The question is that where it should map, where it should map. So there is a formula, and the formula is what? C equals to M mod number of blocks in the cache memory. Number of blocks. So first of all, we have to find out that how many blocks are there in the cache memory. So let's say I have a cache memory, and we have 100 blocks in the cache memory. Obviously, we have a main memory, and obviously it is more than 100. It's not comparable. Students, it's not comparable. So there is a formula that we have to follow. C equals to M mod number of blocks of the cache memory. So to illustrate this one, I have taken an example. Okay. So example is that it's a cache memory which is consisting of 128 blocks. It's a very small cache memory, and each block is containing 16 words. Each block is containing 16 words, and I have taken the main memory which is addressable by 16-bit address. Here the total blocks of main memory is how many blocks? 4096 blocks. Obviously, there if the cache memory contains 16 word each, so obviously it's mandatory that the main memory also contains 16 words. Okay, so in each block 16 words. So in this way we have we have taken the example. So by this formula, let's say I will apply the formula C equals to M mod 128. Okay, just we'll move to the diagram. Okay, so dear students, just see the diagram is like this. Here there is a small cache memory. Okay, as in the diagram, as you can see, this is your cache memory, this one. Okay, this is the cache memory, and this is the big one is your main memory. Okay, here the question is that a particular block of main memory will be mapped to the cache memory. Now the question is that where it will be mapped. Okay, so if we will apply the formula C equals to M mod 128, let's say for an example we will take the example of 255. Will example 255. So B 255, whatever it is written over here, it is to be mapped to cache memory. So when we will apply the formula C equals to M mod 128, mod means what? Modulo function. That means it will give us the reminder. So after calculating, we can got it that the modulus, the reminder will be 127. Okay. So in this case, so as in the diagram, as you can see that here the reminder is 127. In the same way, if we can consider that, let's say another block at the same time want to come into the cache memory, then let's say as in the diagram, for easiness I have drawn this. So let's say another block 127, block number 127 of the main memory. Obviously, after calculating the formula, after putting the formula, it is also coming the same block, that is 127. Then again, as per the diagram, another case, then let's say the B0 of main memory, then B25 6 256. Okay, 256 of main memory, it is also mapped to a same block. Okay, so now the question is that how exactly the mapping function occurs. For this mapping function, the CPU generates the address, and the CPU address is of 16-bit. Okay, and here the address is being divided into tag, block, and word. Okay, so tag bit is used for indicating whether the particular word particular address is found in the cache memory or not, and if it is found, if it is yes, then in which block, and again which word, because 16 number of words are there, which word is required. If it is it is required, then the word number. Okay, now the next is what is the advantage. Advantage, obviously it's a simplest method, because we'll just implement it, and we'll just put the formula and it will implement it. Okay. And disadvantage is what? There will be a contention problem, because for a single block, the contention means what? For a single block of cache memory, the more than one block of main memory is competing, so there will be a contention problem. So to improve this cache mapping techniques, we'll use the second method in the second class. Okay, that is a associative mapping. So thank you for this. Okay, have a nice day.